Hi, I'm Rishika, the graphics champion for Luminara Zoo in Nocturnal Studios, and I'll be highlighting my personal contributions. In Milestone 1, my work was centered on the project's technical setup. This included scaffolding the project on Windows, setting up CMake, generating the Visual Studio solution, integrating third-party libraries, and organizing the source tree into a clearer structure. Another area I supported was tools and workflows. My contributions here include a level editor functionality, drag and drop and click interaction updates, prefabs, and scene JSON setup, and later on, installer and packaging tasks. I also took on several gameplay-related and technical support features such as camera controls, scene switching, play and exit flow, toy hide and reveal logic, FPS display, animal logic fixes, and some early AI experimentation. My main technical focus across milestones 1 to 5 was rendering and engine integration. This included graphics system support, JSON-driven rendering integration, scene-level VFX, and the layering system across graphics, logic, physics, and collision. Outside of coding, I also contributed via minigame ideation and by helping to refine story ending concepts with teammates. The visuals on the left provides examples of the kind of features and systems I worked on across different stages of development. These are the evidences. I worked on the CMake build configuration. This included integrating third-party libraries such as GLFW, GLEW, and GLM, as well as organizing source and header discovery within the project structure. This was part of establishing the technical foundation of the engine, and it supported both project setup and solution generation for development. From there, I moved into the graphics side by working on the renderer foundation. Here, I was setting up 2D orthographic rendering, viewport resizing, blending, and the initial rendering pipeline needed to display graphical content. This was part of my early graphics works and helped create the base for later visual and scene-related features. As development progressed, I began working on prefab integration via JSON. The goal here was to move towards a more data-driven workflow where changes in config files could be reflected directly in the engine. This phase also involved connecting transform-related behavior with prefab config. In other words, properties such as size, interactivity, and object behavior could be described via JSON and then interpreted by the system. Beyond rendering integration, I also worked on connecting prefab-driven elements to gameplay flow. An example of this was integrating button-related behavior with the game state system, such as supporting play, quit, and scene-related transitions. I also contributed to the integration between Game State Manager and the ECS structure. This work was more engine-side and it reflects how my role extended beyond just visuals. Another area I worked on was 2D camera behavior. This included zooming behavior, smoothing, and scene-related fixes so the camera behavior felt more controlled and consistent. I also explored some early AI-related implementation. This was not meant to be a final polished AI system, but more of an experimentation phase involving simple behavior logic and ECS side support for AI states. Later on, I also contributed to the installer and packaging support. This involved working on installation and uninstallation setup, as well as preparing the files required for delivery. In Milestone 5, the work became more focused on scene-level facial polish. An example of that was adjusting particle system and scene VFX across different parts of the game. Beyond my main graphics role, I also contributed via gameplay and narrative ideation, taking part in discussions on mini-game ideas, story progression, and possible endings. One of my main contributions was helping the UX3D student develop a key finding and password unlocking ending concept, which evolved from a more sci-fi-inspired idea into a simpler and more practical gameplay direction. I also joined discussions on a healing-based shooting minigame involving sick animals. The screenshots on this slide supports these contributions by showing early concept discussions, ending references, and cutscene animation ideas, reflecting my involvement beyond technical implementation. The following are examples of more ideations ranging from robots taking care of animals to foodie sizzle game inspiration, although not all my ideas were implemented. As the only RTIs member in the team, I had to be more independent and flexible in how I supported the project. While my main role was graphics, I also contributed via integration work, discussions, and technical problem solving. This project helped me build more confidence in shaders, particles, rendering systems, and scene-level polish. Weekly consultations also gave me a better understanding of teamwork and production overflow. Thank you.